Turkey has taken a significant step forward in strengthening its maritime strike capabilities and air power by successfully firing a new long-range anti-ship missile, LRASM, launched from a fighter jet. This milestone reflects the growing maturity of Turkey's defense industry and its ambition to achieve greater strategic autonomy in advanced missile technology. The LRASM was developed to address the weaknesses of older generation anti-ship missiles, which were vulnerable to modern air defense and electronic warfare systems. With cutting-edge technology, the LRASM takes naval warfare to a whole new level. One of the LRASM's key strengths lies in its stealth design. The missile's body is designed with a special geometry to reduce its radar cross-section (RC), making it difficult to detect by modern warship radars. The LRASM is designed as a long-range anti-ship missile, with an operational range exceeding 370 kilometers, allowing launches from outside enemy defense zones. This range provides a significant strategic advantage because the launch platform does not need to approach dangerous areas. The LRASM is more than just a conventional guided missile. This missile is equipped with artificial intelligence, AI, and a high-level autonomous system that enables it to autonomously identify targets, select ships of highest strategic value, and avoid decoys and false targets. Continuing missions even after losing GPS signal makes the LRASM extremely difficult to intercept, even in intense electronic warfare environments. This combination of sensors allows the LRASM to operate effectively in adverse weather conditions, at night, and in environments full of electronic jamming. Even if one sensor is disrupted, the remaining systems can still ensure mission success. In the modern era, electronic warfare is a crucial factor. The LRASM is specifically designed to survive and operate in highly complex electronic warfare (EW) environments. The LRASM carries a high destructive warhead designed to disable even large warships. It not only destroys the hull but also targets vital systems such as the command center, radar system, engine room, and weapon system. In addition to its physical form, the LRASM is also coated with radar-absorbing material, allowing it to approach targets undetected at very close range. This capability is crucial when confronting warships equipped with multi-layered air defense systems such as the Aegis combat system. In modern naval warfare, superiority is no longer determined solely by the number of ships or fleet size, but rather by the ability to strike precision strikes from long range, defend against electronic warfare, and destroy high-value targets. One weapon system specifically designed to meet these challenges is the LRASM long-range anti-ship missile. This missile is considered one of the most advanced anti-ship missiles in the world today. The successful air launch test of the new LRASM marks a major breakthrough for Turkey's indigenous defense program. Long-range anti-ship missiles are among the most complex weapon systems to develop, requiring advanced propulsion, guidance, target recognition, and electronic warfare capabilities. This achievement aligns with Turkey's long-term defense strategy, which prioritizes reducing reliance on foreign suppliers while expanding domestic research, development, and production. Over the past decade, Turkey has invested heavily in missile systems, sensors, avionics, and fighter aircraft integration. The LRASM test demonstrates how these investments are now yielding tangible operational results. Launching long-range anti-ship missiles from fighter jets offers significant tactical advantages. Unlike ship launch systems, air-launched missiles benefit from higher launch altitudes, greater flexibility, and faster response times. Fighter jets can quickly reposition, penetrate contested airspace, and engage naval targets far over the horizon. In a recent test, the missile was launched from a Turkish fighter jet, demonstrating the seamless integration between the missile system and the aircraft's avionics, radar, and mission computer. This integration is crucial, as modern anti-ship warfare relies on networked operations, where aircraft, satellites, drones, and naval platforms share data in real time to locate, track, and attack enemy vessels. Turkey's new LRASM is designed to operate in highly contested maritime environments. Modern naval battlefields are saturated with radar systems, electronic countermeasures, and layered air defenses. To survive and succeed, an anti-ship missile must combine stealth, intelligence, and adaptability. Key capabilities demonstrated or associated with the missile include long-range strike capability, allowing engagement of enemy surface combatants from a safe standoff distance, low observable design, reducing detection by enemy radars, and increasing survivability. The successful test significantly enhances Turkey's maritime deterrence posture. Surrounded by strategically vital seas, the Aegean Sea, the Eastern Mediterranean, the Black Sea, and access to key maritime choke points, Turkey places great importance on naval and air power integration. An air-launched long-range anti-ship missile provides the Turkish armed forces with the ability to deny Hostile naval forces access to critical sea lanes. This capability is particularly relevant in scenarios involving carrier strike groups, amphibious task forces, or heavily defended surface combatants. By holding such assets at risk from long distances, Türkiye strengthens its deterrence and crisis response options. The LRASM test also highlights the growing sophistication of Türkiye's Air Force ecosystem. Modern fighter jets are no longer standalone platforms. They serve as nodes in a broader combat network. The integration of long-range anti-ship missiles complements other assets such as unmanned aerial vehicles, UAVs, airborne early warning aircraft, and reconnaissance satellites. Türkiye's experience in integrating advanced weapons onto its aircraft, both manned and unmanned, has accelerated in recent years. This experience reduces development risks and shortens timelines for operational deployment. The LRASM test indicates that Turkish engineers have mastered complex tasks such as software integration, flight testing, and weapons certification. The successful test is likely to have a notable impact on regional security dynamics. As naval modernization accelerates across multiple regions, long-range precision strike capabilities are becoming a central element of power projection. Türkiye's entry into this domain alters calculations for potential adversaries and reinforces its role as a major regional military power. Rather than escalating tensions, such capabilities often serve as stabilizing factors by increasing deterrence. When states possess credible, advanced defensive and offensive systems, the cost of aggression rises, encouraging diplomatic solutions and strategic caution. Beyond domestic use, the new LRASM may also open opportunities for defense exports and international cooperation. Many countries seek cost-effective yet advanced anti-ship solutions compatible with existing fighter fleets. Türkiye's defense industry has already built a strong export portfolio in drones, armored vehicles, and missile systems. If the missile continues to perform successfully in subsequent tests and enters full-scale production, it could attract interest from partner nations seeking to enhance their maritime strike capabilities without overdependence on traditional suppliers.